In this last section, we're going to be solving for x when the function has a given value. That's different from letting x equal a certain value. So in A, we have f of x equals 5x minus 3. Our task is to find x if f of x equals 7. Since f of x equals 7, that means that f of x can be replaced with 7. So I'm going to replace the f of x with 7, and from there I'm going to solve for x. Add 3 to both sides, and then divide by 5, and we get x equal to 2. So what this is saying, thought bubble here, is that f of 2 must equal 7. All right, in B, if g of x is equal to the square root of x plus 2 minus 3, we're going to find x if g of x is equal to 1. So we're going to replace the g of x with a 1. And remember, we need to isolate that square root, so we'll add 3 to both sides, and then square both sides, and subtract 2, and that's going to give us an x value of 14. So remember, this is basically saying g of 14 does equal 1. All right, in C, we're finding x if h of x is equal to 4, so I'm going to replace the h of x with 4. And we need to multiply through by the denominator, clear those fractions. So 4 times x minus 1 is equal to x plus 3. That gives us 4x minus 4 is equal to x plus 3. Let's subtract x from both sides and then add 4. So 3x is equal to 7. That's going to give us x is equal to 7/3. And lastly, k of x equals x squared minus 6x. We're finding x if k of x is equal to 2. So we'll replace the k of x with 2. This is a super nice one to solve by completing the square. So I'm going to insert a plus blank on both sides. You maybe remember the shortcut there for completing the square, but I always do a little box there. It's x squared in the upper left, and divide that 6x into 2 equal pieces, negative 3x and negative 3x. Now let's construct the factors. X times x, and remember we want identical factors. That's the reason why we're putting negative 3x, equal parts of the middle term in both of those diagonal boxes. So completing the square would give us a 9. So 11 must equal x minus 3 times itself, or x minus 3 squared. Now we can solve by taking a square root. Plus or minus the square root of 11 must equal x minus 3. So x can equal 3 plus the square root of 11, or 3 minus the square root of 11 once we add 3 to both sides. Not 111, just plain old 11. All right, and that's the solution for that one. It's your turn now. F of x equals x squared. Find x if f of x equals 12. Well, I hope you remembered 2 things. I hope you remembered that there were 2 solutions, since this is a quadratic equation, so you had to use plus or minus to take a square root. And I hope you also remembered to simplify that square root. We want our answer in simplest form, so the square root of 12 simplifies to 2 root 3. Now try B. In B, when we substitute 1 and multiply both sides by x plus 2, we get a contradiction. That is to say, when we subtract x from both sides, we get 2 is equal to negative 3, which is not possible. So no value of x will make g of x equal to 1. And that's it for this part of this section.